All right, now that we're done with fluids, we're going to move on to the two new units in thermodynamics. The first one will be heat, and the second one will be thermodynamics. But what we need to do first is review what temperature and kinetic energy are and look back a little bit to what we saw in chemistry. If you've already taken it, if you haven't, this will be the first time you see it, but I promise, nothing too bad. It's mostly straightforward relationships, either going to be linear or inverse relationships that we'll see. So let's start with a little review from chem. And the first thing is an atom. What is an atom? Well, an atom is the smallest particle with physical properties. Any smaller than an atom, things start only displaying like chemical properties, and it gets weird. It doesn't work the same way as you would think. And how do they move? They move with Brownian motion. If you guys have ever played the original Half-Life, there was an achievement where there's a guy in the bathroom, and he's asking for toilet paper. So the game tries to teach you how to pick stuff up and move it. If you drop toilet paper over the top into the stall for him, you get an achievement called Brownian motion. But what is Brownian motion? It's basically where a whole object remains still, but individual particles move in tiny erratic motions. In tiny, erratic, and seemingly random, but it's not. Oops, I forgot my ing. Seemingly random paths. So right now, I am standing here. I'm not moving, but all the particles in my body are bouncing around moving. Cool. Now that we've got that, let's talk about heat and temperature. Heat and temp. So heat is the thermal energy of a system. We'll clarify this a little more in the next set of notes that we go through. But basically, heat is the transfer, whereas the total thermal energy of a system is going to be what we call internal energy. But for now, this working definition will work for us. And heat depends on the velocity, the number, and the type of particle. More velocity you got, faster they're moving, higher average kinetic energy, so there's going to be higher heat. The more particles you got, there's going to be more energy in the system, obviously, if there's more particles there to have them. And then the type, the bigger they are, the more energy they're going to carry with them. Heat is measured in joules. LOL, Mr. Gillum said joules. Okay, get the laughs out, LOL.com. And then the next one that we're going to talk about, temperature. So temperature is the average kinetic energy of particles in a system. And you can measure this in a variety of ways, which we will go over. Cool beans.